Morning guys, sorry I couldn't be there today. So today what we're going to be doing is we're going to be continuing our discussion with right triangle trigonometry. I'm going to try to make a video to see if we can get through this still, and then tomorrow I'll answer any questions that you guys have. We'll review for the test, and the test will take on Wednesday. So let's review the two standards that we've already reviewed once. The first one was where we're talking about sine and cosine being complementary angles. And then the trig ratios and Pythagorean theorem used to solve right triangles in applied problems. So let's take a look at the first type of problem. You should have a half sheet that you can get that has this problem on it along with a couple others. Just make sure you have that sheet out. Okay, so on this problem it says, can you find the value of each missing angle inside in this triangle? Round answers to the nearest thousandth. So it says the missing angle inside in this triangle. So if we look, we have a missing angle here, and then we have two missing sides in the triangle. So what we're going to do is first, let's find the angle. So we're going to find x. So what I'm going to do is set up a little area to do this problem. So x is a missing angle in the triangle, and we know that the two acute angles in a right triangle, so these two angles, have to add up to be 90 degrees. So all we have to do is say, well, 23 plus x equals 90. That's our equation, and we just subtract from x, and we should get that this angle is 67 degrees. So that was kind of easy. We'll find out later some other ways to find angles. Okay, so let's take a look at the next piece. Why don't we find, just stick alphabetical order here, and we'll find y. So y is a side of the triangle. And so what we're going to do is we're going to use the pieces in the triangle that they gave us to find this value of y. So they gave us this 23 degrees, and they gave us this 18, and we want to find y. So just like we always do, you look at your equation, or you look at your triangle, and you find the piece they gave you. They gave us this angle, and they gave us this 18, which we know is the opposite side. And we want to find y, and that's next to the angle, and it's not the hypotenuse, so it must be the adjacent side. So if we have opposite and adjacent, we know that that is going to be the tangent function. So when we write our equation, we say the tangent of the angle is equal to the opposite over the adjacent. Now we know when we solve this equation, we're going to end up with y is equal to 18 over the tangent of 23. Oops. So why don't you guys put that in your calculator and make sure you can get the correct answer. And what you should get is y is equal to 42.405. Alright, so that's the value of y. So we just have one more that we need to find. And notice, all we're doing is using the pieces that they give us in the problem to solve for the missing pieces. So our third piece, we called it z. So let's set up a little area to solve for z. Okay, so z, that is the hypotenuse of our triangle. So if we're looking at our angle 23, and we're looking at this 18, the two pieces they gave us, that opposite side, we have 18 opposite z hypotenuse, and we know that opposite over hypotenuse is going to be the sine function. So our equation should be the sine of 23 is equal to the opposite over the hypotenuse. Okay, so to solve for z, we know that when the variable is on the bottom, we're going to end up with an equation that looks like this. Z is equal to 18 over the sine of 23. And then from there, we just put it in our calculator. So try to put that in your calculator, see what answer you get. And you should get 46.067. Alright, so take a minute, think about what we just did in that problem, review each one, and then we'll take a look at the next one. Okay, so our next problem, it says one more time, find the value of all the missing angles and sides. Why don't we do this one? Let's round to the nearest hundredth. Round to the nearest hundredth. That's just to throw in a little change into the problem. Alright, so let's give each of the missing pieces a variable so that way we know what we're solving for. So we have the side here that we're missing, side x. Then we're also missing this angle, we'll call it y. And missing this angle, we'll call z. So we have to find each of those missing pieces. So again, let's just go alphabetically here. Let's solve for x first. So to solve for x, we know this is a side of the triangle. But with this one, we already have two sides. So to solve for the third side, what we can use is that Pythagorean theorem. So remember, if you know two sides of a right triangle, you can always find the third using the Pythagorean theorem. So we'll make a little note there. Two sides can find the third. So if we look at our pieces here, 5, we have, that's the hypotenuse, that must be our C. And then A and B are going to be our two legs of the triangle. So let's put those values in. We got the square root of 21 squared plus x squared. Again, I'm just substituting in those values into the equation here, is equal to 5 squared. So let's solve here. Square root of 21 squared equals 21 plus x squared is equal to 25. So from here we just solve. So we're going to subtract 21 from both sides. And we get x squared is equal to 4. So x squared equals 4. To solve for x, we got to take the square root to cancel out the square. Those two cancel, and we get x is equal to the square root of 4, or 2. Remember, when you take a square root, it's really plus or minus, but since we're solving for a distance, it has to be that plus. So our answer is just 2. So x is equal to 2. All right, let's take a look at our next piece. We want to solve for y. So let's set up over here. Y, we know, is an angle. So to solve for an angle, what we want to do is we're going to do the same thing we always do. We're going to look at the angle and identify the sides they gave us. So they gave us this side A, or this side square root of 21, really. And so that would be adjacent to angle y. And then they gave us this 5, which is the hypotenuse of the triangle. So in that case, we have adjacent and hypotenuse, so we know we have to set up a cosine equation, because cosine is adjacent over hypotenuse. So do the cosine of our angle, what we don't know y, is equal to the adjacent side, square root of 21, over 5. Now to solve this, just like we did on Friday, I think in first and third block, and I'm not sure if we got to it in second, but it's a very simple concept. We need to get rid of cosine to solve for y. So to do that, we take the inverse cosine. And what that is the inverse cosine of both sides. So take it of that side. This looks crazy, but all that happens is this inverse cosine cancels out the cosine. And if I did it to that side of the equation, I have to do it to this side, so I get the inverse cosine of square root of 21 over 5. Then from there, these cancel. I'm left with y. And on this side, I just need to put the inverse cosine of the square root of 21 over 5 in the calculator. Now to do this inverse cosine, all you need to do is press that second button, the green button, and then press the cosine button. From there you put that in your calculator, and you should get y is equal to 23.578. And since this is an angle, we're going to put a degree symbol. But hold on, we're rounding to the nearest hundredth. So we're going to round that 578 to just 5.8 degrees. Now what I want you guys to do is try to make sure that you get that answer before you let the video go to the next part. Alright, so our third piece we want to find is angle Z. So angle Z, we know that is in fact an angle. So we're going to set this problem up the same basic way we did the last one for angle Y. We're going to look at the sides they gave us. So from Z, the square root of 21 is no longer the adjacent side, it is the opposite side. And 5 is still the hypotenuse. So now when we have opposite and hypotenuse, we need to use the sine function. So we're going to say the sine of angle Z is equal to opposite square root of 21 over the hypotenuse 5. So now when we solve this, we just have to do the inverse sine to get rid of the sine function. And so we get Z is equal to the inverse sine of the square root of 21 divided by 5. From there you put that in your calculator and you should get 66.42 degrees. And that's it. So notice these problems, it's just the same thing every time. We're using right triangle trig like we did for angle Y or angle Z, or we're using another problem or another equation for triangles to solve for those missing pieces. You just have to know what can I use to solve for those missing pieces. Okay, so now that you guys have seen a few examples of those, what I'd like you to do is, since you're sitting in groups, I want you guys to number yourselves 1 through 4. So one person on the table will be number 1, one person will be number 2, one person 3, and then one person 4. So take a second and number yourselves 1 through 4. Okay, so what I want you guys to do, Ms. Smith should hand you out a paper now if she hasn't already gotten it to you. And I want you guys to try number 3. And then so what we're going to do is each member of the team is going to solve for a certain piece of the triangle. So first off, the first team member, number 1, is going to solve for the hypotenuse of the triangle. Team member number 2 is going to solve for the top acute angle. And then finally, team member 3 is going to solve for the bottom acute angle. Team member 4, your job is to make sure that the team stays on task, and you're going to check and confirm that you agree with the work that the rest of your team has done. So take about 5 to 10 minutes to do that, and then you guys can compare your answers with the answers I'm going to put up, as well as the answers of your classmates. Go ahead and pause now. Okay, so here are the answers that you should have gotten for this problem. So if you want to review those answers, take a minute to do that. If you need to pause, feel free to do it. Okay, so let's take a look at the next set of problems I want you guys to try. We got new assignments for each team member. So problem number 5 on the assignment that you have. What I want is team member 1 to find the length of the horizontal leg. Team member number 2 is going to be checking the work and keeping team on task. Team number 3 is going to find the measure of the other acute angle. Pay attention to that one. It's easier than you think it might be. And team member 4, find the length of the vertical leg. Okay, so take a minute, try out those problems. And again, I will put up the answers and you guys can check them out. But pause the video now and come back and check later. All right, so here are the answers I got for team member number 1. I made that X. For team member number 2, that's the Y value. And then for team member 4, that's the Z value. And hopefully team member number 2, I think I said 2 earlier, I meant to say 3 for Y, but team member number 2, hopefully you kept them all on task and you guys were able to check those answers and you got them all correct. Okay, so now I have one other thing to look at today, and that is draw your own picture problems, or as you guys call them, word problems. All right, so let's take a quick look. So the first problem, we're talking about a crow. So let's read it here. A crow is on the ground 80 feet from the base of a 45 foot tall tree. It then flies straight through the air to the top of the tree. What is the angle of the crow's flight path relative to the ground? Okay, so I call these draw the picture problems because that's basically what you have to do, is draw a picture. So since we're doing right triangle trig, the picture we should draw is a right triangle. So got a right triangle there. Let's read through. It says a crow is on the ground. So here's our crow. It's got little wings there and little feet and kind of looks like a person now, but it's a crow. It's 80 feet from the base of a tall tree. So 80 feet away. And the tree, it says, is 45 feet tall. So I put the 45 on that vertical distance because that's how you measure a height. And then it's on the ground for that 80 feet, so that's where I put the 80. Okay, then it says it flies straight through the air to the top of the tree. So its flight path is the hypotenuse of this triangle. It says, what is the angle of the crow's flight path relative to the ground? So we have to look which one of these two angles, this one up here or this one here, is relative to the ground. It's going to be this one that makes an angle with the ground. So this is what we're looking for. So if we're looking for an angle, we know that we're going to use inverse trig. Keep that in mind. Anytime you're looking for the angle, you're using those inverse functions. But before we do that, we need to figure out which one we're going to do, so we have to set up an equation. So we got angle x. This is our opposite side, 45, and then our adjacent side, 80. So all we have to do, we have opposite and adjacent out of SOHCAHTOA. That's going to be the tangent, opposite and adjacent. So we'll say the tangent of angle x, the angle we don't know, is equal to opposite 45. You go across the triangle to get to it, over adjacent 80. It's next to angle x. So we solve this for x by getting the inverse tangent. So x is equal to the inverse tangent of 45 over 80. From there, we just need to put that problem into a calculator. So the answer we should get is 29.358 degrees. Alright, but that's all it is to word problems. You draw, because this is right triangle trig, we're going to draw a picture of a right triangle and label the pieces they give us in that triangle. So before we move on, I do have a quick joke for you guys. Why do crows never get hit by cars? Well, they're always warning each other. Car, car. Alright, so let's take a look at one thing we need to add to word problems. And it's just 2 vocab words that we need to know, but it's very simple to pick up. So these 2 words are angle of elevation and angle of depression. So these angles are actually the same exact angle, just in 2 different situations. So the angle of elevation is formed with a line that'd be kind of along the ground, and the hypotenuse of the right triangle looking up. Where the angle of depression is kind of a horizontal line up in the air and the hypotenuse looking down. But they're actually both congruent angles because they're really alternate interior angles with each other. So the way I remember this, an angle of elevation, if you're elevating, you're looking up. An angle of depression, if you're sad, you're looking down. So that's kind of how I think of those. So depression is when you're looking down, and elevation is when you're looking up. Okay, so we got one more problem. Let's take a look at what it says. Suppose you're flying a kite, and it gets caught at the top of a tree. You've let out 100 feet of string for the kite, and the angle of depression, keyword we just learned, angle of depression, from the top of the tree is 75 degrees. Instead of worrying about how to get your kite back, you wonder, how tall is that tree? So let's go ahead and draw a quick tree here. Let's get a nice brown color for our tree. So tree, say the tree is a little hole for an owl to hide in, but anyways, here we go. Nice, lovely tree. So our kite, which will say, let's say we got a blue kite here, is stuck right at the top of this tree. So there's our kite, and it's stuck right at the top, and we've let out all 100 feet of the string. We're pulling onto it pretty tightly here. So it says you've let out all 100 feet of the string, so there is the 100 feet of string for the kite, and we know that the angle of depression from the top of the tree is 75 degrees. How we know that, no one will ever know, but the angle of depression here is 75 degrees. Now notice, I drew the angle of depression at the top of the tree as opposed to down on the ground here. And the reason for that is because an angle of depression means you're going from the top and you're looking down. Keep in mind depression, if you're sad, you're depressed, you're looking down. So that's the way I kind of remember that phrase. So anyways, the next question says, we want to figure out how tall is that tree. So the way I think about that is that would be the distance from the top of the tree here to the point where we're standing at here. So this would represent the height of the tree. Because I move this line over here, it would just be that line there, the height of the tree. So to get the height of the tree, x, what we're going to need to do is set up a right triangle trig problem. If you look, we have this right triangle with this imaginary line going across the top here, our vertical line here, and then the length of our kite string here. So if we look, we have our angle 75. We have this x as the opposite side of the angle, and then 100, well, that's the hypotenuse. So if we have opposite and hypotenuse, we should know by now that that is our sine function. So we're going to use sine of our angle, because the angle always goes with the trig function. Sine of 75 is going to equal to the opposite side x over the hypotenuse 100. From there, we're going to solve by multiplying both sides by 100. We get x is equal to 100 times the sine of 75. So now from here, all we do is put that into our calculators, and we should get 96.593 feet. So that shows us how tall this tree must be. That's a pretty tall tree, 96 feet. How we got our kite that high, I do not know. Alright guys, from here, there are some practice problems I want you to try just to make sure that you're kind of getting this, and then we'll do a quick review, and that'll be the lesson for the day. So on the worksheet that had solving the triangles, I want you on the back, there should be a couple word problems. I want you to try problems 1 through 3, see how you guys do on those, and I'll put the answers that you should have got on this page momentarily. Just pause now and come back when you got them. Right, so here are the answers that I got for each one of those problems. If you guys want to take a look, pay attention to where I labeled the parts in the triangle and see if those make sense to you, as well as pay attention to the answers to make sure that you're getting consistent answers with what I got. So I got for the first one, the second one, and the third one. So if you need to pause to review those, by all means do that, and I would recommend it. And from there, we have a couple review questions, and that'll be it for the lesson. And basically what I want you guys to do is finish that worksheet that you got today on this stuff. Okay, so here's a quick recap questions. I'd like you guys to once again pause and take a look, try to answer these questions. Go ahead and pause now. Okay, so let's take a look at the answers. When using inverse trig, what are you solving for? You're solving for the angle, to be more specific, the acute angle of a right triangle. Okay. Next question, in triangle ABC, where C is the right angle. So let's go ahead and draw a quick right triangle there. ABC, where C is the right angle. What other trig function would equal the cosine of B? So we know the other acute angle is going to be A, and we know that the cosine of one angle is equal to the sine of the other acute angle. So it's going to be the sine of A. And keep in mind that angle A, measure of angle A plus the measure of angle B has to equal 90. But your answer to this problem is in fact the sine of A. Okay, so that's those two. And then finally it says solve for the missing parts of the right triangle. So we have to solve for all three parts. Let's do that fairly quickly here. Let's start with x, that is the hypotenuse of our right triangle. And we are given two other sides. So if we're solving for the third side, remember, if you know 2 to find the third, it's just a simple Pythagorean theorem problem. So we get this, 8 squared plus 15 squared is equal to x squared, because c is always the hypotenuse and x is the hypotenuse. We solve this out and we get 17 is equal to x. Okay, so that was solving for x there. We solve for y, so we're looking at this angle. That's going to make 15. Remember, we're only going to use the sides that are the values they already gave us, in this case, these two sides. Opposite of y is 15, and adjacent to y is 8. So if I have opposite and adjacent, that means I have to use the tangent function. So we're going to say the tangent of our angle, in this case, y, is equal to the opposite over the adjacent. So keep in mind, guys, these problems, it's just 3 separate problems, but it's all on the same triangle. So from here we solve by doing inverse trig, because as question number 1 says, when you solve for an angle, you use inverse trig. So use inverse tangent of 15 over 8, and we solve that by getting an answer of 61.928 degrees. Now we're going to do the same thing over here at angle Z. So angle Z, from this angle, 8 is now our opposite side, and 15 is now the adjacent side. So again, we have opposite and adjacent, so we're going to use the tangent again. And the tangent of Z is going to be 8 over 15. So then to solve for Z, we're going to do the inverse tangent of 8 over 15. And we put that in our calculators. And we get 28.072 degrees. Now if you check angle Z plus angle Y, because they're both the acute angles of our right triangle, should add up to 90. So if you check that out, see what you get. So that's really all I have for you guys today. So what I'd like you to do is work on the worksheet that you got today that has these types of problems on it, the word problems and solving a triangle. You need as much practice as you can with this. So work on those, and we'll see you guys tomorrow to go over the review for the test, and then we'll test on Wednesday. Have a good day, guys.